Hi everyone. The topic of this lecture is to discuss about the special sign convention which is applied to internal forces in multi-force members. Remember, we are analyzing or discussing about beams, and beams are multi-force members, and therefore they normally will have internal forces in terms of axial force, shear force, and bending moment. And therefore, it is important to establish a sign convention for these internal forces that will then indicate the effect of these forces on the beam that we are analyzing. Now, one thing important that you need to remember is this sign convention is different than the one that we have been using for writing equilibrium equations, for example. So it's important again to distinguish between these two different sign conventions. Now, the sign convention for internal forces is given by definition in the following way. So if we have a beam, a multi-force member, and we want to analyze the internal forces at a certain location, we cut the beam at that location, and then we can draw the resulting free body diagrams. The left-hand member, the right-hand member. Now, if the forces act in these directions internally, and you can see they have opposite directions on each side of free body diagram, for equilibrium, of course. If the forces act like so, meaning axial force pulling outwards, shear force pushing downwards, and bending moment rotating counterclockwise on the left-hand side free body diagram, and of course having the opposite directions on the right-hand side free body diagram, these are positive internal forces. Now, if these forces act in the other direction, in the opposite way, as you can hear, the axial force pushing into the member, the shear force directed upwards, and the bending moment being clockwise on the left-hand side of the free body diagram, then these constitute negative internal forces. And of course, they have opposite signs on the right-hand side free body diagram. So these are the two situations, the sign conventions. Of course, these internal forces are not necessarily all positive or all negative. It could be a combination of them. So some could be negative, some could be positive, depending on what's happening on the beam and the supports of the beam and the general configuration and so forth. Now, these internal forces might not tell us too much, but it may be more intuitive if we look at the effects of the external forces when these internal forces are present. So for example, if we take the case of the axial force and we draw again the two free body diagrams as before, now a little thicker, showing the depth of the member. This is positive internal axial forces. In order to have these, the blue arrows are the external forces that will pull the member to the left and to the right, like so. So this is positive axial force again. What that means is those blue forces tend to elongate the member, so the member will be in tension. See, very easily now, if we look at the effect of the external forces, we can see the member will be in tension. In the other case is when the internal forces for the axial force is negative. So now the blue arrows, the external forces, will push the member, trying to make it shorter. So a negative axial force is equivalent to the member being in compression. Very, very intuitive. A second case for the shear force. Now the shear force tends to break the member in the same way as you cut, say, paper with the scissors. So this would be the left-hand side of the free body diagram. And now the right-hand side of the free body diagram, offset like this, assuming the member has failed due to shear. So positive shear on the left-hand side going down, and going up on the right hand side. So for equilibrium, the external forces have to be like so. So pushing up on the left hand side of the free body diagram, pushing down on the right hand side of the free body diagram. This is the positive shear force. We show it usually with a symbol like that, that shows the deformed shape of the beam once it failed in shear. So higher on the left side, lower on the right side. And now the opposite case again. The internal shear force will now go up on the left hand side of the free body diagram and down on the right hand side of the free body diagram. And the effect of the total forces acting externally on the beam look like the blue arrows, pushing down on the left hand side, pushing up on the right hand side. So this will mean that the shear force is negative, or we can use that symbol again. Finally, with regard to the bending moment, I'm going to draw again the left hand side of the free body diagram and the right hand side of the free body diagram bent, very exaggerately bent, as you can see. This would be positive bending moment internally, so counterclockwise on the left hand side. In order for equilibrium, in order to obtain these internal moments, we would have to bend the beams as shown by the blue arrows, and that would make the beam bend downwards, or would make the beam sag. This corresponds to positive bending moment, or we can use a smiley, a happy smiley like this one, showing the shape of the beam when it sags. Then, if the beam bends the other way, like so, and the internal bending moment is clockwise on the left hand side of the free body diagram, then these blue arrows will show the effect of the external forces on the beam, making the beam to bend upwards, so making the beam hog. So the beam is now hogging due to negative internal bending moment. And we can symbolize this again with a smiley, a sad smiley this time. And we can also show the signs, as you can see, positive, negative for the bending moments in these little symbols. As well, we can do the same for the symbols for the shear force. So thank you very much for watching this lecture, and I will see you at the next one.